Alright, should be making a video and do the little preliminary actions that increase the efficiency of the video. Yeah, I suppose. Whatever. Alright. Done, I think. Alright, so there is a new video by the Dispar guy, and it says 2 draft science, so they don't respond to any arguments made for 2 years, and then they expect me to respond to their tripe. What is your formula to predict the, So because they made a silly formula that has plus and minus momentum in it, plus and minus energy, subtractable energy, and I'm claiming that formula clearly is nonsense and doesn't correctly predict anything. So it's a lot like the Young double slit analysis, where if you follow the Young diagram, you will not get the right answers. You'll get wrong answers. You won't be predicting the double slit. You will be predicting a version of a single slit experiment because of the fact that you've destroyed all the capacity of the double slit features to be seen in the pattern. You won't produce them. And so you're obviously not predicting double slit patterns, you're predicting single slit patterns. Anyway, so it's garbage math, frankly. And the bastardization of creating some derivative, some version of saying that mv equals 1/2 mv squared, and that's essentially what they've done, is made two unequal answers equal to each other and created a Frankenstein equation that has pluses and minus momentum in it, and it doesn't make any sense. You have only one momentum going into the experiment, and you end up with two momentums coming out in some cases in opposite directions, and you pretend they're capable of undoing each other's action. The action A undoes action B, which can happen. So it all has to do with scalars and their vectors and just these bullshit words that don't mean anything. They weren't real. They're not real assignments. They didn't discover them in nature. There's no evidence that momentum, the energy of momentum, is any different than the energy of kinetic energy. A train hits you, you're not going to be saying, oh yes, the kinetic energy was whatever 500 joules and the momentum was only 250. Not going to happen. That looks a little overexposed, but we'll see if we can get, it doesn't take that long to see if I can fix it. It helped a little. See if it'll help more if I do it twice. Alright, let's try to reduce brightness a little here. It's probably too much, but that's okay. Too much can't hurt much. Alright, so this is where you're going to and from, is the idea that you have a one mass hits a one mass. Alright, and there are two conditions to understand. So, elastic versus inelastic. The idea would be, and then super elastic. So the idea is you do this with hard objects. It should be the same as if you put a spring in here. Okay. So, and in this case, it doesn't matter, right? In this case, the spring, no spring, hard metal hitting hard metal, Newton's cradle works fine, no springs. Put a spring in, still works fine. So all the energy goes, 100% of this, okay, goes out here. Okay, no problem. Conserve the momentum, bingo. Now from there, you're going to go in two directions. I guess I'll have to draw higher. My mistake, but I'm not going to redraw it. Okay, so now the idea is you're going to go from a 1 to something less than. Okay, so now we're going to go a little smaller. Okay, so some point, okay, x. So 1 in, point x out, and in this other case you're going to have 1, going the other direction. You're going to have something that's 1 plus. Okay, 1 plus. So you can go two different directions, and what's going to happen in those two cases is, in this case, when this one's always heavier, okay, so we're going to go all the way to eventually we'll have the 100% of the energy here. And we're going to hit something so light that it's going to be almost a complete transfer, except for it's going to be 999. 99, sorry. 99.999, okay, percent of the, no, the lighter thing I hit, the smaller the percentage, sorry. So this will be near zero. So this goes to near zero, 0.1 kind of thing. Really small amount of energy, because this thing will be so small. Okay, so it becomes really small. This thing just pushes it right with it, and only a tiny percentage of energy is used to push the thing because it's so tiny. So it's you pushing a pea or something, or a kernel of corn. Whatever speed you're going, the little kernel of corn is going to take a little tiny bit of your momentum, but it'll be infinitesimally small. And so 100 just stays here. The energy stays here in this case, okay? And they end up both going in the same direction and mostly at the same speed. And that's the difference, though, between elastic and super elastic, because it's the same, almost the same speed if you're unaided by a spring. But if I put a spring in here, I'll get a different answer, in the sense that the spring will store a tiny bit of energy and then release it evenly in both directions. So it'll give this one a little extra velocity. So instead of 0.1, it'll have 0.3% of the energy. So the spring will aid in the transfer of the energy and allow you to transfer a little bit more. So this will be, only 99 point whatever 7% of the energy stays here, and a little bit goes there. So that's that extreme. And then when you go this other way, where you're hitting the one mass against eventually a gigantic, unmovable object, you're going to get 100% of the energy back in the same direction. So in that sense, these two things are the same in the sense that but the directions are going to be exactly the opposite, and that the energy is retained by the object that originally goes in. So in both cases, as you go to the extremes, this one object doesn't transfer very much energy. So you get a complete bounce off the hard object, the infinitely heavy, and just progressively different going to the 100, but it's always just 100%. You have to have 100% of the energy, and it doesn't matter which direction it's going. So somewhere here in the middle, what you're going to end up doing is transferring, part of the energy to this object, and you're going to guess that it has to go half the speed of that, okay, or something much less than half the speed because it's a heavier mass. So because this is a heavier mass, I guess we're going to make it look heavier. Whatever percentage it takes, it's, if it takes 50%, it's only going to be 25% of the velocity. So say if it took 50% of the momentum, that would only mean 25% of the velocity. And so it would have to be 3/4 of the mass, and this would take the other 25% of the, the other 50%. Ooh, sorry. At also the reduced, the velocity would be, I have to think about that. Well, whatever. Let's just say it's 50%. So it's going to be some percentage. So the idea is that's what makes all this a little tricky, is that when the objects that you're hitting gets heavier, you start to reflect. So you can't transfer. So you go from 100% to something less than 100% in terms of what you transfer, and the rest has to come back in a reflection. So the heavier this gets, the bigger the reflection, okay, and the lighter it gets, the smaller the reflection. So, when this is just 1 pound, like say just one unit, this weighs 100 and this one weighs 99, there's just going to be a tiny difference. Well, I should have done it the other way around. This one weighs 100 and this one weighs 99. It's a little tiny bit heavier. then a little tiny bit of the energy goes back as a reflection, just 1%, just a tiny bit, and the rest goes into the object. And as it gets heavier and heavier and heavier, you have less percentage and more percentage reflect. So it's 100% reflection at the maximum here, and it's almost 100% continuation in this case, just because your mass has gotten so infinitesimally small. So I don't think there's any simple equation you can write, because this is a transition through this middle. Okay, this middle is the place where the rules change. So you can't write one equation that's going to answer all these questions. You basically have to understand that the condition of the equation is you're hitting something heavier than you are, or you're hitting something lighter than you are. Then you can write an equation for how the transfer might take place under two different conditions, and you have to make a distinction between ones with springs and ones without springs, because springs change the circumstance because they are actually a storage device. So this was an argument I would make, is you obviously in these experiments don't want to ever compress the spring all the way. So that's another thing that people don't seem to understand, is there's a functional range for the spring here to here. So you kind of want, that's the part that you want to use. You never want to compress the spring that much, okay? You only want to compress it to a size like that, because you only want to take advantage of you want to keep within the range of its function. And certain people don't pay any attention to those kind of rules. So if the spring is really loose and weak, then it gets all the way compressed and it stops storing any more energy. So it has to be stiff enough where it doesn't compress all the way when the two things hit each other, so then it can give it back. But the idea is the spring is loose. When the object comes in, it's going to create the same pressure on both sides as it compresses. It's going to be pushing both ways. But the trick is it can push at either speed. So it can push slow for the big mass, and it can push fast, okay, for the smaller mass. This can go fast away from the spring, and this can go slower away from the spring, and the spring will release the same amount of energy. It's just releasing it in one case more quickly. Alright, so I don't know if there's much else to say. So he wants an equation for this whole thing. Newton didn't have one, and Descartes didn't have one, and Galileo didn't have one, because frankly it's pretty much two different kinds of experiments. The results are so opposite each other, it's pretty hard to write an equation that works for both, unless you can do pluses and minuses. Unless you can sit there and say this is a minus direction and you're going to start subtracting it or adding it. And that's why I would say their equation is completely bogus, is because it considers motion this way as being opposite or subtractive. So you could have 50% of the energy go this way, and you could still have 100% go that way, because then you'd only have 50 and 50. Well, whatever, you know the math. You have 50 going in, and yet you could have 150 coming out, which can't happen in reality. Alright, so I think that's enough of a context. And then we'll play his ragged, stupid, moronic video. I'm sure that's what it is. They always are. So we turn this back on, and we hit this stupid link. So apparently he is going to talk in this video, so that's a little better. Alright, so hopefully the audio will be of a reasonable microphone quality and such. So he said, alright.
So here I am with my voice.
Yes, good. So that wasn't too hard after all, was it? A little more volume, I think.
Voice and my face showing. I hope you're glad now. No more typing. Anyway, so I've been playing around with these
Well, the argument would be is you play my video like you did. You play the clip of me saying things, and then you refute what I said. So I've had clips where I'm describing how a lever works, or I have clips where I'm describing how hydraulics work, and then you explain where I'm making mistakes. That's sort of the idea.
The formula that predicts the velocity outcomes of cart 1 and cart 2 after collision in an elastic collision.
So, and again, I've just pointed out how elastic doesn't mean anything. Okay, it's just a silly word because the two circumstances, spring and no spring, are both called elastic. So you have to make a distinction. Now, Brozo found that he couldn't make the free momentum experiment on the air track. He couldn't make it work without the springs. So it's clearly not an elastic phenomenon. Somehow springs are magical and they allow the extra energy to show up. So you have to concede that that's a fact in this history and have that as a context. That why do you need springs? Should be one of the questions you ask. Well, how are springs magical? How do springs make it happen? When we're supposed to be able to Newton's cradle without springs. There's no springs in the Newton's cradle and it works just fine. Why didn't the air track experiment work just fine without springs? It's hard metal against hard metal. Should work just fine.
This same kind of formula that Professor Loon has been writing on his blackboard.
It's the same formula they use to decide the weight of an electron, frankly. Okay, it's, this is a combination of two ideas, momentum and kinetic energy, and they smash it together, and this is the Frankenstein that's the product. They put the kinetic energy brain in the momentum body, and they make a mess.
Which is this one over here. And so V1 is the cart 1 bouncing back after collision. Now we are not really interested in that. We're mostly interested in the second cart being pushed forwards, which is V2. And this is the formula: 2 times mass 1 divided by mass 1 plus mass 2 times U1, which is the initial velocity, plus M2 minus M1 divided by M1 plus M2 times the second velocity, but that's only if the second cart is also moving before collision. And what we are talking about is a situation where cart 2 is standing still and cart 1 is colliding into it. So the velocity of this one would be 0. So if you times it times 0, this whole thing becomes 0. So we can just skip this.
This whole thing that you can't see. So you can't see your mouse or anything. So who knows exactly what you're talking about. But who cares? Yes, we have the idea here. We have this pluses and minuses, which are, in my opinion, not going to be able to tell you anything. Yeah.
We can cancel it. We only need this part. So this part here, that's the most important one. So now I was wondering, Draft Science, if you also have a formula like this, because I've been watching many of your live streams and your videos.
I would say first, if you're going to use springs, you have to add the spring constant, so that's going to affect it. And the argument I would make to you is simply that if you're going to do an equation, obviously the equation has to be different for when you're hitting something heavier than when you're hitting something lighter, because the outcomes are dramatically different. There's no reflection, okay? There's nothing going in opposite directions when you hit something lighter, and there clearly is something going in an opposite direction when you don't. It's almost theoretically difficult to create elasticity in the forward direction. That is, to give something more velocity than you're going to end up having, because basically it's hard to hit it and make it go a velocity you don't have. I can run at a certain speed. That's how fast I can run. If I hit something, I can only push it the same speed I'm going. I can't push it faster than I'm going.
In the last year, but I didn't really notice you writing an actual formula like.
Well, I think it should be clear from watching the channel, I really don't give a fuck about formulas. I don't need to know how many gallons of gas I have to put in my satellite to make it orbit to, a frog in space. I don't care. So what do I need math for? Math isn't conceptually helpful. So I'm not saying you can't write math, but I'm saying why would I write math for something as simple as a universe that's basically 2 plus 2 plus 2 physics? I don't need mathematics to understand why an electron repels another electron or why it, attracts two protons. So what do I need the math for exactly? How is the math the theory exactly? Why don't you explain how math, that the physical universe is made out of math? Because it fucking isn't.
Mainstream science has a formula to predict the outcomes of the velocities after collision.
Yeah, and as I pointed out, I think it's absolute crap and nonsense. It's clearly creating free momentum, which is nonsense. It destroys energy all over the place. They bang a you can watch the experiment, okay? They do the experiment. I've drawn this so many times. They do the experiment with a ticker tape, okay? They have a 5-pound cart going 10 miles an hour. They drop another 5 tons on it, and then it leaves as a 10-ton cart going 5 miles an hour. Almost perfectly. A tiny loss of energy, okay? Momentum. Tiny. Infinitesimally small almost. It's so small in the experiment. It never goes faster, right? So it always goes that little bit of lost momentum. So it loses a little tiny bit of momentum. That's it. And your formula says it lost half its energy. Okay? So what am I going to say? You have a ridiculous formula, okay? Because it clearly didn't do all that. You clearly can't make sounds and bend metal and do all that crap without using your momentum. If I crash into a car, my car loses its momentum, okay, to bend the other car and to bend my fenders and all that crap. That all absorbs the energy, and now the car moves a lot slower because it's bending pieces. It's using the momentum to bend the metal. You can't bend it for free. You can't make noises for free. You can't make heat for free. You have to use something's energy to do it, something's momentum. So telling me you have a formula when it doesn't work, it's on its face stupid. Why should I be impressed? Why should I be impressed by your horrible formula that doesn't actually predict what happens?
So I was just I was looking to find a formula for you, and maybe you already did this, but nevertheless, so based on the assumption that after collision, let's say a 1 to 2 ratio, for example, here, 3 kilograms colliding into 6 kilograms, the initial velocity is 4 meters per second. After the collision, car 2 will come out with half the speed at best, which is 2 meters per second.
Right, but it's not going to do that, right? Because it's a much heavier object, so it's going to reflect. So it's not going to be half the speed. It's going to be something less than half the speed. I mean, you don't understand what best means. Best means if it was a perfect universe, I guess, or if it was in space or something, maybe there's a condition you can create where that best happens. But I'm not arguing the best happens. I'm arguing that, yes, if you do this experiment on an air track, a substantial portion of the energy will be pushed into the 6 kilograms, but there will be a minor reflection. Some portion of the energy won't be put into the heavier mass. That's why the Newton's cradle can't do this. If I do it with a Newton's cradle, it doesn't fucking work. Okay, the fact is there will be a reflection, and the two objects will be moving at different velocities. So, I mean, fuck you. This is, we've already been over it. So yeah, it's going to be the 6 kilogram object's going to be moving something less than half the speed of the 3 kilogram by rules. Okay, so if it's going 4, this one's going to be going 1.8 or 7, some kind of number like that. And the other object will reflect with the 0.3. Shit.
Now, what formula would that be to give this prediction? also, what would be the prediction if we have other masses? Let's say a 2.6 kilograms versus a 3.4 kilograms, like totally other numbers, other.
So again, you're saying that there's some obligation that the universe works a way that you can simply formalize, and I guess my argument is that the formula is not going to be simple because it really does matter. Now, why exactly all these experiments haven't been done by now? Okay, where yes, they do the slow motion camera on the Newton's cradle and they throw these different masses at each other, and then do it with springs and without springs and all that stuff. Well, that's the world we exist in. So, but that's what Descartes attempted. Okay, so Descartes had 6, 7 rules for how these collisions work. 7 different rules. You know, you're not going to put 7 different rules into one formula. So there's a rule for when you're heavier and lighter. There's a rule for when you're made of the same substance. There's a rule. There's a rule. So you got to follow all those rules first to sit there and decide what experiment you're doing and what the rules are going to be for that experiment. Aluminum is different than steel, right? So when steel hits steel, you know, it's a much quicker, the speed of sound in steel is much higher than the speed of sound in aluminum. You know, these things all matter.
Masses. What would the outcome be? What would be your prediction? What kind of
The predictions I've already given you, so fuck you. I don't need math. I can tell you the prediction, okay, that a certain percentage within a certain range is going to go one way, and a certain amount is going to go the other way. So I've been quite clear. As you go lighter, as you hit lighter things, you both go in the same direction. As you hit heavier things, you end up going in opposite directions. So fuck you.
formula would predict that? So I came up with this one, and I'm just wondering, am I correct? 2 times mass 1 divided by mass 2 times the initial velocity divided by 2. For example, if we have
No. That's assuming that all the energy goes into the second object. So what the fuck good is that? The initial velocity divided by 2. It's not 50-50. It's when the initial thing happens, right? Especially with a spring. So again, these are spring experiments you've seen, not non-spring experiments. So understand what's happening. You're hitting the lighter thing is hitting into the heavier thing. There's a certain amount of transfer that can take place. The idea is this: the spring mitigates. So the spring allows that to happen. That actually does happen. The spring compresses till the pressure builds up. It starts moving this object. And then the spring is moving with the experiment, then it expands. And then it gives 50-50. So you could argue the spring can give 50-50. So whatever energy you initially compress the spring with, that energy will be released in both directions. Okay, but obviously if the object's still moving this way, if it has more mass than the spring compression, it's still going this way, so it's not going to accept the energy, it's going to reflect it. So it's really, you're just really saying the spring is just a mitigator to the reflections. It's going to allow for a longer time of contact and allow there to be more reflections back and forth. This, when the energy goes into the object, right, you hit something, the energy goes into this object, it bounces back. If there's a spring there, well then the spring can bounce it back in again and it can reflect again. That kind of stuff can happen. Whatever. I mean, you don't know any of this physics, and you're sitting there demanding some kind of clarity when you can't provide any clarity to how the energy moves in the objects, or how it moves in springs, or how any of this happens. And you're declaring that your physics is already built and constructed, and you already have an answer. And my clear and obvious answer to that is yeah, but you get wrong answers. So what good is your theory or your physics if it doesn't predict accurately? And it doesn't. You don't measure any of this energy you claim to create and destroy.
0.50, so 500 gram colliding into a 0.25 kilogram. That would be the opposite of a 1-to-2 ratio. Now we have a 2-to-1 ratio. So instead of half the speed at best, now it would be double the speed at best.
So again, I never said that in any video ever. I've always said you can't push faster than you're going, so it's just more horse shit. I don't know where you invent this crap, but you can't paraphrase a single fucking thing I say accurately ever. So I don't know whether your ears don't work, I don't know what the fucking problem is, but you clearly can't pay any attention at fucking all. I've never said objects fly off. You hit it with a heavier object and the smaller object flies off at twice the velocity or 10 times the velocity. Never said it. Bullshit. I've described how bowling balls hit bowling pins. I have a whole video explaining how the ball's momentum is given to the pins, and as the ball gives away its momentum, it's losing momentum. So it looks like the pins are flying off the ball, but the fact is the ball is slowing down. The pins aren't going faster than the ball was going. The ball is going slower than the pins are going.
So let's say the initial velocity is 20 meters per second. The half the mass weight would come out with a double the speed, 40 meters per second. So
I've never made a video that ever said this happens ever. Okay, so just absolute horseshit. I have never suggested I can I can move a 10-ton object at 1 mile an hour. I can hit a P and the P will fly off at 50,000 miles an hour. Never suggested it, never talked about it, never drew it. Absolute crap. So fuck you again. You can't paraphrase anything accurately. You're just such an irresponsible, lying, slandering sack of shit.
If we take this formula, 2 times mass 1, which is 1 kilogram, divided by mass 2, which is 0.25 kilogram, times the initial velocity, 20, divided by 2, so which is 10. Do the math, and it will equal 40 meters per second.
Right, and nobody suggested it. It's not my formula.
And if we take this,
pile of shit you made up, okay? And again, you have no qualifications. You've shown no mathematical dexterity. We have no reason to do any of this crap or indulge in any of this crap because I never drew this wacky formula. I never suggested it's how it works. I never even suggested that one formula could answer both questions. And again, Galileo, Descartes, and Newton didn't have one formula to answer the question. Descartes had 7 rules. Newton didn't provide anything but 3 laws as a context. But they didn't answer these questions. They didn't sit there and say, I will predict what will happen in each one of these different events. It was all still a little bit ugly. Because every way you do the experiment, rolling objects is a problem because you got angular momentum. Every single way you do the experiment, they didn't have air tracks. And yes, the Newton's cradle is a pretty damn good one, but they can't see it in real time. They can't see exactly what happens to the 2 objects when they collide, when they don't have the same mass. So fuck you.
These numbers here, 3 kilogram into a 6 kilogram, initial velocity is 4 meters per second. 2 times mass 1, which is going to be 6 kilograms divided by mass 2. 6 divided by 6 equals 1 times the initial velocity divided by 2. So 1 times 2 equals the outcome of 2 meters per second. That's correct. That's in line with your prediction. So I'm wondering, is this
the fact that a formula works for one circumstance doesn't mean anything. That's what this whole conversation is about. The fact that kinetic energy and momentum don't have a conflict as long as you're using objects that have the same mass. But as soon as you use objects that have differing masses, the 2 formulas start diverging dramatically in their statement about reality. Again, the gun-bullet analogy. Momentum says everything's just fine, okay? Half the energy went into the gun, half the energy went into the bullet, and it's perfectly sensible. The momentum is 50-50. All right, your math, your theory says that 1,000 times of the energy went in the bullet and only 0.001% of the energy went into the gun. 1 joule of gun recoil, 1,000 joules of bullet velocity. That's your theory. Completely inconsistent with Newton's third law, clearly. And again, will you just answer the fucking question? I mean, how many times have I suggested the question? You have a spaceship and you're flying through space in a direction. And 1 minute you shoot a bullet out the side of your ship at 2,000 miles an hour. I mean, at 2,000 joules. Let's just say 1,000. 1,000 joules of bullet fly out. One atom going 1,000 miles an hour shoots out of your spaceship this way. And a moment later, you shoot the recoil of the gun out the other side. Okay, so you shoot the 1,000 atoms going 1 mile an hour. So you have 1,000 atoms going 1 mile an hour out one side and 1 atom going 1,000 miles out the other side. You say there's 1,000 times more energy over here than there is going this way. Does the spaceship turn? But you've evaded all of those questions, and then you sit there and you know, insult me by pretending I wrote your retarded formula and stated that's how it happens when I never stated that. I answered the question. The spaceship doesn't change its direction because the only thing that matters is the momentum out this side and the momentum out that side. The only thing that has real energy is real momentum. Kinetic energy is a fable, it's fake, it's virtual, it's nonsense energy. It doesn't exist anywhere in the real physical universe.
Correct formula for every possible prediction, for every possible ratio. Just a question.
Yeah, fuck you.
Is this your formula to predict?
I'll say again, why I don't need a formula. What does a formula have to do with anything? Again, I don't understand why you think formulas prove physics. They don't. Okay, experiments prove physics. Show me proves physics. Alright, some fucking formula doesn't.
Every possible outcome for every possible ratios.
And again, why would anybody even think formulas could do that when there's obviously two fundamentally different things that happen? So how the fuck could you possibly describe they both go in the same direction and they have opposite motions in a formula that you don't start using pointing vectors and the rest of it? You have to do a bunch of abstract math to be able to put in the math some variable that will figure out that going this way is real energy. It's not unenergy. This way isn't anti-energy. Fuck you.
Alright, so that's going to be the video.
Yeah, well, it's a piece of shit. So why don't you just answer my fucking question that I have asked 400 times. Do you believe in conservation of momentum or not? Alright, do you believe in Newton's third law or not? What happens to the fucking spaceship, fuckhead? And then explain to me when you concede the spaceship just keeps going straight. Well, then why don't you explain how that's possible? How it's possible that I released 1,000 joules, 1,000 watts of heat in one direction, right? We could all just convert it into heat. I released 1,000 watts of heat in one direction, and I only released 1 watt of heat in the other direction, and somehow my ship stays straight. How is that possible? So Stephen Bro doesn't write a comment. Amazing. Just a sentence. Yeah, he's really, I guess he's planning his trip to Hawaii or something. I'm guessing he will sense this as a trap by having to tie himself down to an actual formula. So this is another guy who never uses a formula, never talks about it, couldn't care less about math himself, and he's playing the game. He understands this is conceptual. You don't need math. You just, more than Pythagorean math. You certainly need to understand geometry and motion in 3 dimensions, but you don't need anything else, frankly. Math doesn't solve the problem of understanding it conceptually. He will weasel out of it somehow. Weasel out of exactly what? clearly it's you people thinking it's as simple as one formula that is broken the physics. It wasn't, again, it wasn't Galileo, Descartes, or Newton's idea to give you one formula that answers all the questions, beyond Newton saying, hey, it's always 100% momentum and you have to conserve it. Okay, so whatever you have to conserve it. That's all. That's all you have to do. Just keep track of the MVs and everything is fine. So that's my formula. MV equals energy. Okay, so just follow the MVs and you don't have a problem. So the Ian Gosling lying sack of smelly shit also says, well done, Dispar. You know, whatever. Godfrey, 3 reasons Gary doesn't waste right formulas for his hypothesis. Let's see. So again, where did a formula ever do anything of value? The Schrodinger equation? Do you think it's a real equation? You think it really is connected to reality somehow? An equation that basically has a symbol in it that says knowledge of everything. So it has a symbol in the formula that says basically knowledge of everything. So without knowledge of everything, you can never really solve the equation. Okay, it doesn't mean anything. All right, it would be conceding that he has the burden of proof. So again, what a joke. They don't have to prove any of their physics, don't have to show any experiments, and show a formula that gets wrong answers, and that's okay. So this Godfrey douchebag would probably defend still, even though I've already shown how it can't possibly produce the correct answer, the Young double slit analysis. He would say the Young drawing of 2 waves can make a double slit pattern. 2 waves can make a double slit pattern. It's not possible, okay? It is factually impossible. He'd still defend it. So he just doesn't care about anything coming close to the truth. Just anything that touches the truth, he finds it repugnant. All right, it would make his ideas testable. So again, how is it a formula change whether it's testable or not? I've already told you the theory, okay? If the object's heavier, you're getting a reflection. If the object's lighter, you're not getting a reflection. I'm already giving you pretty much the guidelines for how it's going to come out. But I'm conceding that every time you do the experiment, there's going to be subtle variables that are going to make the difference. It's not going to be exactly 1/3 going this way and exactly 2/3 going that way or any of that crap. Because it's really going to depend on spring constants and a lot of other things. So you don't want to pay any attention. You really don't think the spring constant is going to matter? When I do this experiment, you don't think the spring constant matters? It's not playing a role? All right. It would make his ideas testable, which would lead to results he can't weasel out of with word game rhetoric. So again, you weasel out with no evidence. You have 0 evidence defending your theories. All right. It's provable that you get wrong answers, and you just keep sitting there saying you've got the most proven theory in the history of mankind when you have the most unproven religion in the history of mankind. They had more evidence of Jesus' existence than your silly, whatever you want to call this crocoduck that you've invented. He doesn't understand the math. I'll concede that, probably 50% of the math physicists do, I would say, is completely... It might as well be made out of actual drool because it's so nonsensical. All right. I predict the response will be 1 mv times 1 v1 equals mass 2 times. Yes, that's also correct. That the total momentum is going to remain the total. Okay, and that's all you're going to get. You're not going to get more momentum out. And it doesn't matter what direction it's going. So there won't be any minus signs, that's for sure. Alright. But what a fucking, it's just, again, they just superficially pretend these experiments are so simple when clearly there's an interesting phenomena taking place. And again, it's one that I would argue casts doubt on the theory of relativity because of the very fact that these 2 extreme outcomes, okay, for banging an ultralight thing into a very heavy thing and a very heavy thing into an ultralight thing, those 2 experiments have such extremely different outcomes, in terms of the separation distance between the objects, that you really can't argue that relativity is a real thing because those two experiments should be inverses of each other. They should look the same. The equivalency principle says they should be the same, and they're not. Alright, so, yeah, so that's all there was. Right, nothing else. Let's just make sure. So all of them just little putrid comments. Nothing to even see here. Seems to be an extra one here. Nice one to spar. This is what I predict. So what's this? No doubt a waste of time is what it's going to be. I predict a riot. Oh, so it's a music video. Yeah, that's just so charming. Alright. So, we'll call this a video, and we'll see if anybody has anything to say, and I'll just get out of here. So it's not a subject that deserves all of this time, frankly. I mean, their theory is you can make free momentum. They don't take any account for it. They just pretend it doesn't matter. I showed how the free energy machine works. They didn't have an answer to it. This weasel, the spar character, made the video. He just basically says, I don't know. Yeah, I guess you could get your free energy machine to work. So he says, the free energy device, and he provides no explanation for why it won't work. Nothing. Just says, yeah, our physics says so, so our physics must be true, so yeah, but I don't know why it doesn't work. Does that mean something's wrong somewhere when something doesn't work? Does that mean something's broken? Oh, I didn't know that's what that means. When something doesn't work, it means it's broken? Oh. Such dishonesty. Despicable. Despicable characters. 9 viewers. Not too good. But that's alright. I didn't have the video on, huh? You didn't really need to see it, right? Yeah. What the hell is this so small for? Something got way screwed up here. I don't know what the hell's going on. Alright. Yeah, I still don't know why this is doing what it's doing. Anyway, what I need is that little chat window thing, right? Yeah. That's the thing that's missing. Alright. Wow, you're still alive. So, ooh, fuck you. You know? Wow, how disappointing that you still are. Fuck. I just, you know, with humans, it's just so useless. Alright, so why isn't this showing? Maybe it has to be up higher. Yeah, that's what it has to be. Alright, so the Virgo says, if some of the force bits reflect for free, so who says that? How does gravity works? So the subject really isn't gravity. The simple argument is that gravity is a nuclear force. And so if there's an electron and it's not moving, and a force bit hits it, and now it's moving, it's going to move less than the speed of the force bit by a substantial amount. So there's going to be less stuff moving into the universe at a speed. This little force bit isn't going to get where it would have gone. It's sort of lost energy by going slow. So by moving the matter bit from here to here, which really can't matter in the long term, over a long period of time it can't matter because all this can do is hit stuff it was going to hit anyway. So moving from here to here won't mean it hit more stuff in the long term. It can't change how much stuff hits it. It's getting hit at a constant rate by stuff. It can move from here to here and it gets hit by more stuff for a moment, but then it's back to the same stuff all the time. There's only a certain amount of energy in the universe, only a certain amount it can hit it. So all you can do is change the amount of time. You can't change the amount of energy. But the fact that this force bit didn't get where it was going, that fact you can't undo. So the fact that the piece of matter moved from here to here is irrelevant because it won't use up, it doesn't change the universe any in terms of making more force somewhere or more speed. Where the fact that this piece of force lost momentum, essentially, if you add up its whole life in the universe, it's not going the speed of light when you add up all the little things it hit and moved slower when it was doing that. So when it's pushing something, it's going much slower. So in fact, the force bit that hits matter, or electrons, or pushes electrons, has a lot less momentum in the universe. So the idea is that the Earth is here, it has a bunch of electrons and protons in it. All the ones that are moving are essentially absorbing energy in a direction, the direction they're moving. They're taking the force out of the force. They're making the force go slower than the speed of light, therefore have less momentum. So less energy comes out, less momentum comes out of the Earth than went into the Earth. And the difference is the motion of the matter. That's the explanation of gravity. I mean, I've done lots of videos explaining the concept. And so, I mean, you know, I'm not going to re-tutor you over and over again. What about the two negative? Fuck you. I'm not doing this. Whatever game you're playing, I'm not going to play it, okay? The two negative objects? What are you talking about? That are attracted together by gravity? I don't even know what the fuck you're talking about. What are negative objects? Opposites attract, okay? Two negatives don't attract. So I don't even know what you're, you know, I can't even understand what possible context that pile of shit of rubbish words has to what you're fucking saying. Oh, by the way, the Merker guy, you left some fucking link, okay, if you watch this video, on the last video to a video that doesn't play. So, you know, you really should annotate. If you're going to post a link to a video, you should say what it is. You should give some clue, response video, or a video indicating, or some, you know, some kind of statement. So you don't end up doing what I just did, which is link to some music video. Some douchebag thinks it's all a big joke. Physics is a joke subject. Don't have to take any of it seriously. Two forces are at play. What, I don't know, what does that even mean again? Two forces are at play. What the fuck? You know, obviously I don't think there's two forces. So fuck you again. Well, I don't know. What are you arguing? I don't believe there's any kind of electrical force or magnetic force or gravitational force. It's all the same fucking force. I'm talking about the elemental function, the quanta of energy, as Einstein would say. The quanta. Okay? It does different things. You call magnetism, or you call electricity, or you call gravity. But it's just the same force, and all you can do is, as I just pointed out, is the simple mechanism for consuming the force is going the speed of light. It hits a piece of electron or a proton, and the electron and proton move. That's the only way electrons and protons move. They have to collect force, and in that process the force is now not moving at the speed of light in the universe anymore. It's essentially been taken out of the game, the going the speed of light game. And that's the deficit that creates gravity. When you move an electron or a proton in a direction, you essentially create gravity in the direction of its motion. You create an absence of energy in the direction of its motion because you've taken the speed of light and diminished it a little in the force bit. And obviously it's a minuscule amount. That's why you need a gigantic Earth to create a reasonably strong force. Alright, so he says, two forces are at play, electromagnetism and gravity. Eventually, gravity takes over. So again, there's no such thing. Gravity is just happens to be, okay, a different phenomenon of the force, right? I mean, the fact that the forces are actually reflecting between two protons, for example, and creating ping pong balls, creating pressure, is different than ping pong balls moving slower, right? Those are two different phenomenon, okay? And so gravity is a byproduct that it takes energy to move matter, and the charge phenomenon is just a byproduct of the fact that the object either absorbs energy, accepts it, or rejects it. Wait, so gravity is electromagnetism? No. There's only one fucking force in the universe. That's why it's all moving the same speed. There's one fucking force. 2 plus, I mean, I've already been through this. There's proton force and electron force. They look exactly the same, except they're a different color, let's say. And then there's electrons and protons, and there's two simple rules about how they interact. But the simplest thing I can say to you is that when a force bit, a bit of force, hits an electron or a proton, it doesn't make the electron go the speed of light. No, it pushes it at a much slower speed because the matter is a lot heavier than the little bits of force. Fuckhead. But, look, I'm not going to tutor you, so if you don't want to watch any of my videos, that's your prerogative. But I've done plenty of, overview videos, different kinds of videos explaining the basic mechanics, the 2+2 videos. Fuck you. I'm really just not going to tutor you in every fucking goddamn comment section. Sorry, I didn't mean to type. I'm half asleep. Well, whatever that means. So, whatever. You don't have to apologize. I mean, I just said in yesterday's video, I was explaining how a magnet works. Now, a magnet doesn't make energy. There's not a bunch of stuff flying out of the center of the magnet. The magnet doesn't have a nuclear core. It doesn't have some way to make photons or radiation. So all it can do is reflect the world that comes into it. And the trick that the magnet is doing is that it's converting it. It's like putting on rose-colored glasses. It's like taking, again, the universe is in these two forms of proton energy and electron energy. And so it's all purpley. And a magnet is basically saying, I can see the blue and I can see the red, and I'm going to separate them. I'm going to make the red go this way and the blue is going to go that way, at a 45-degree angle. And so essentially I'm segregating the two colors. So I'm taking purple and converting it into blue and red. I mean, something that simple. Now, the details you don't do in a chat, frankly. But yeah, that simple concept works to understand why magnets don't need an energy source, why magnets don't need a fission engine, why magnets are perpetual and forever. It's because all they're doing is filtering what's hitting them. It's just like the Earth does some of that, right? I mean, it takes the ultraviolet energy and converts it into infrared energy. So it's still, the Earth's already doing something like that. So it's not so hard to understand that you hit a material. Even every object that has a color, it's already doing that. It's absorbing some energy and reflecting other kinds of energy. It's filtering it. And that's all magnets are doing. They're filtering what's hitting them. This red isn't screaming red at the world, right? It's the light is hitting it, the white light, and it's coming back just red because it's absorbing all the other colors. I mean, fuck. The concept is easily understood. Electrons and protons, they are not producing the field. The field is a reflection off of them. Everything We call matter only reflects or absorbs energy. That's it. And absorbs means it only temporarily absorbs, okay? It moves in a direction because of the absorption. I didn't say you can't use the same bits that you use for electromagnetism. My point is gravity works without charge. I'm just saying that you're saying it works without charge, which doesn't mean anything because it only works with material objects that are made of electrons and protons. So I'm just saying atoms don't work without charge, retard. So, your argument is moot. And gravity is only one directional for electrons and protons. Electrons and protons don't have any gravity, okay, until they move towards each other. They have to be moving towards each other for each other to feel the difference in the pressure. So they're neutral until they create the motion towards each other, and then they have some gravity. Because they are creating gravity by moving. There's no gravity until an electron or a proton moves. If they don't move, there's no gravity. You could argue that neutron stars, theoretically, okay, would have very little gravity because there's very little motion, right? But they have a lot of magnetism because they're definitely segregated the electrons and protons and stacked them magnetically. So they'd be incredibly magnetic, but very ungravitational. Because gravity requires electrons and protons to be moving. And I don't mean moving in a direction, I mean moving. Moving. Jittering. Jiggling, as Feynman would say. You have to jiggle an electron to create gravity. You have to jiggle a proton to create gravity. If you really could super freeze a planet, my argument would be it would produce no gravity. Because it would just reflect energy, or energy would just pass through it. There would be no way for it to move anything. I suppose it could be a tiny amount of gravity if I think about it, right? Because you could think that the energy that didn't just reflect off one of the little frozen bits that went in, that actually had, went in a little bit and then it reflected and it got trapped inside and started bouncing off all the little bits that are frozen inside, that it could be trapped for a little while. And that being trapped for a little while would create a tiny, tiny, tiny amount of gravity. Gravity increases with mass, not charge. Well, how do you know? I mean, obviously if I add two charges, I've increased the charge. So that's just a lie. So, fuck you, you're a liar. 2 electrons has twice the charge of 1 electron. 3 electrons has 3 times the charge of 1 electron. I mean, it's just idiotic to say it doesn't increase with mass. The fact that electrons and protons are different, you can't sit there and say, because the electron and the proton have a different mass, therefore charge doesn't change with mass. Of course it still can. Electrons and protons aren't the same object. But the objects in question are neutral. Who says you? That doesn't mean anything. Fuck you. It's absolute babble. The objects in question are neutral? What are you talking about? An electron is completely the opposite of a proton in this one aspect. And they have another aspect that's different in terms of their density. So protons are more dense And that's it. So you can understand them as just having those two differences. They're oppositely charged, and the proton is 1,000 times denser. Now, I'm not going to say for real that it's exactly the numbers they produce, because their numbers are produced by the mv squared formula. But it's clear that the protons are stuck in the nucleus, which indicates the protons aren't mobile. They don't move as well. And that's why they're nuclear bits rather than external bits. There's no way to weigh an atomic particle, except to measure its velocity. And how do you measure that? You have to measure it relative to something else's motion. So you're, in so many respects, you're out of luck to sit there and say that you know how much a proton weighs, because you can't really do an experiment to dissect its weight. We don't have enough control over force or energy to do that. I mean, the assumptions made are just kind of grotesque, in terms of they're just formulaic. There's no experimental verification of the amount of energy that's in an electron gun, for example. I guess he was talking about the objects in question are neutral. He's talking about neutrons. I've already explained. Look, again, if you're not going to watch any of my previous videos, there's no point in doing this. Neutrons are composite objects, proton and an electron. They're not neutral. Okay, they're just complete in the sense they have a positive and a negative. So, that's their neutrality. So depending on, if you could imagine I could have a blue and a red thing, and if I spun them really fast, all you'd see is purple. So you can understand they could look neutral, but it doesn't mean they are neutral. They're a dipole. There's only two elemental matter bits. There's just electrons and protons. There's nothing else. There's no quarks, there's no sporks, there's no positrons, there's no taus, there's no muons, there's no gluons. All that crap is either an electron or a proton in collection. Two electrons together, close together, two protons close together, different arrangements of electrons and protons moving. That's all there really is in the universe. That's the only thing matter is doing. The real universe is just made out of two kinds of planets. Okay, the red ones and the blue ones, the electrons and the protons, and they're the same size because they have the same charge potential. And the only argument is the red ones are a lot heavier. In the simulation, when a force bit is absorbed, does it continue moving in the same direction through the object? It doesn't move through. I said stick about 7,000 times. It just sticks to it. So whether it moves through or not is irrelevant. It just sticks. It hits it. This is the force bit. It hits and it sticks. And if this already has motion in this direction, then it's a combination. Obviously you just add the momentums. So you change its direction a little bit and you make it go a little faster. That's all you can do, is increase its acceleration. So if you hit it directly in the direction it's going, so it's going 5 miles an hour, you hit it with the speed of light, little tiny force, it adds momentum in the direction it's going to add more than if it goes at a vector. Now that part's not in the simulation yet because that's a little more complicated math, because you have to do the incremental additions of velocity, and my argument is you really can't add velocity incrementally. You can only add it in a direction, so it gets a little more complicated. You have to do some averaging. because it's the only way to make the simulation run, because you can't do too many complex mathematical functions and actually have the thing run at a speed that's watchable. But anyway, regardless, it's a minor detail. But the point is it's absorbed while it's stuck, and then when a force comes from the opposite direction and hits this moving piece of mass, the simple argument is the force does exactly what you expect. There's a force stuck to the matter here, and then this one's going to hit it, and the two forces are just going to reflect. And now the matter has nothing. And it has to wait for something else to hit it and push it in a direction. So it's just getting pushed. Matter just gets pushed by force. The force never dies. The force never is nowhere. I've stated in these videos that you've been in the chat, I've stated this point, okay, that clearly force can only be in two conditions: freely flying through empty space, being meaningless, or pushing a piece of matter. So it's either every force bit in the universe is either right now stuck to an electron or proton and pushing it, or it's flying through empty space. Those are the only two conditions the force bit can be in. Either stuck to an electron or proton, or freely flying. That's the only two conditions. And the only two conditions for a piece of matter is, it can have no force stuck to it, or it's being pushed somewhere. It's moving somewhere by the force. It's moving in a direction. And every trillisecond it gets changed in its direction because force hits it from different directions with different amounts every trillisecond. Alright, does it continue moving in the same direction through the object, or do you scatter the force bit in all directions to release it? Obviously, one force bit can't scatter in all directions, and no, nothing ever changes its momentum vector. The momentum vectors are all correctly added up, and you can't just go in some random direction. It's always a mathematical certainty. The angles always have to be Pythagorean three-dimensionally correct. It's a pool table in 3 dimensions, you know. I mean, it's really not that complicated. Maybe you could make a pool table with a bunch of BBs that were constantly moving and bouncing off the sides of the pool table. You would see the phenomenon happen, okay, in the sense that, you know, if I could make such a scenario and then I could drop billiard balls into the scenario, the billiard balls wouldn't end up moving into each other. It'd be for a slightly different reason, because obviously you have to do all the rules, so the BBs would have to stick and all that kind of crap to actually create the same phenomenon as charge. But again, charge is a little more complicated than just saying gravity. Gravity you can create without even worrying about absorption. All you need is the reflections. That is disappointing. People never stay on the subject. Just never do it. So, Virgo guy, what do you think happens to the spaceship? So I shoot a bullet. No, I shoot one atom going 1,000 miles an hour out one side of my spaceship, and then a trillisecond later, I shoot one atom going. No, 1,000 atoms going 1 mile an hour. So I shoot one atom going 1,000 miles an hour, and then a moment later I shoot 1,000 atoms going 1 mile an hour out of my spaceship. Does my spaceship stay on course? Or is it radically turned by the 1,000 mile an hour atom that has much higher joules? 1,000 times more joules of energy. If all the force bits just sticks, how do you have I'm just not going to keep doing this. This is bullshit. I thought you said half was absorbed. When did I ever say half is absorbed? What are you even talking about? Depends on how its motion is, what its motion is and where it's moving and how it's jiggling. When did I say half was absorbed? What are you talking about? If all the force bits stick, they don't all stick. I just pointed out to you how if the matter's moving this way, the electron's moving this way, and if force hits it this way, it loses a force bit. One flies out this direction, one flies back this way. I just pointed out if two force bits hit each other, what happens? Well, they both end up going this way, right? Opposite direction. So essentially, this one's still going that way, and this one's still going that way. And it's as if nothing happened at all, except the matter bit in the middle now has no energy pushing it. Retard. Fuck. Hey. I already explained what magnetism is. You cannot magnetize something in any other way than to say you change how it reflects the universe that hits it. Magnetism is not a fucking goddamn special aura energy that something produces. It's just charge. You arrange the charges in a certain way, they create an effect, a pattern. It emits a pattern. A piece of iron can see the pattern. We can't see it. I'd like you to answer my question about the spaceship. I'm certainly arguing that NASA knows the difference. So he's not going to answer it. Or if you're not going to answer my question, guess what? Then I will block you. Because that's just bullshit. But that would be true for both the electron and the proton if they are both sticking the same force bits. Well, I've already said it's 2 plus 2 plus 2 physics, right? There's two kinds of force, two kinds of matter bits. I mean, fuck you. This is nonsense. You're just a troll, right? So this is just, you're just telling me, you're just saying block me, please. Because I'm just going to be insanely redundant. And I'm not going to answer any of your questions. So answer the question or be blocked. That's your choice. Does the spaceship turn or does the spaceship continue on its trajectory? The spaceship gave away one atom going 1,000 miles an hour that way, which means it has to go that way because now obviously it had to produce that 1,000 mile an hour atom. It had to use energy to produce it, the same number of joules to produce it. So it obviously produce those joules in the opposite direction if you want to use your silly physics. I mean, obviously I'm saying it let go of this. That means it's still stuck with an imbalance of this now. It had a balance, now it doesn't have a balance, so that's why it moves. But the fact is it's going to move an amount. And then I let the 1,000 atoms going 1 mile an hour with only 1 joule of energy. It's really easy to make that, apparently. So that's only a little bit of turn back. Tiny, tiny, tiny bit. So now I'm going this way. NASA and me say I'm going straight. You tell me what you think. Your theory says I used 1,000 times more fuel to move the one atom 1,000 miles an hour. So go ahead. Explain how I used 1,000 times more fuel, but I'm still going the same direction. It will remain straight, and the spaceship will also gain heat. I don't even know how that's possible, but okay, fine. It remains going straight. So in spite of the fact that you use 4 times the fuel to do one thing than the other thing, you're going to keep going straight. In spite of Newton's third law, okay, where somehow you're supposed to have the opposite reaction, you're going to continue to go straight. So you're basically conceding the argument. Kinetic energy is bullshit because you've manufactured it out of bullshit. You're saying it doesn't obey Newton's laws. You do understand that's what you've done. That is what you're saying. You're conceding mv squared can't be right. I mean, if you gain heat, you'd have to come out, you have to say you used even more energy. So not only did you use 4 times more energy, somehow you're also creating heat. Did you make more heat when you shot the 1,000 atoms going 1 mile an hour, or did you make more heat when you did the 1 atom 1,000 miles an hour? Which one made more heat, whatever the fuck that is? So just to understand what you just said, right? I used 1,000 times more fuel to do one than the other, and yet they had exactly the same effect. I guess he's saying the when I shot the 1,000 atoms at 1 mile an hour, I made 1,000. I made 1,000 times 1,000 units of heat. Okay, and I didn't make any heat when I did the 1,000 because that's the only way he could make the kinetic energy add up. He has to somehow force moving the 1,000 atoms 1 mile an hour. He has to somehow make that so inefficient that it ends up using the same amount of fuel as the one atom going 1,000 miles an hour. So to make the two things equal, he has to force moving the 1,000 atoms 1 mile an hour to be so insanely inefficient. Like it's impossible to do it without just wasting and squandering huge volumes of energy. I mean, complete nonsense. And that's the physics they defend. Flat Earth stupid. I mean, you just have to be a liar, really, right? Just like a flat earther. You have to be a liar to say that doesn't pose your theory a problem. The very fact that you're contriving this nonsense, that somehow it's almost impossible to move 1,000 atoms 1 mile an hour, and it's really easy to move one atom 1,000 miles an hour. I can do one really efficiently, and I can't do the other one at all without wasting energy all over the place. But the fact is that if they did the experiment, NASA will not find any problems at all. They won't find it at all difficult to move the 1,000 atoms 1 mile an hour. It did exactly the same work. And that's the truth. Because they could use the same lever to do it. They could use the same spring and the same lever, and they could create both effects with the same amount of energy. Oh, you assholes are just in denial. You can't accept that your precious little intellectual physicists, mathematicians aren't brilliantly precise and careful. Can't accept that they're delusionary, knee-jerk, reactionary, phantasmagorical, silly people. If all the force bits stick and reflect. So here he is doing it again. I'm not going to... I just told you, if you're going to keep doing this, forget it. Where did I say all the force bits stick and reflect? They either stick or reflect. They can't do both things at the same time. Then proton and proton can't attract. Why would a proton attract a proton? Can attract. Oh, okay. Well, then look, I'm just saying the simulation works. The rules are so fucking simple. I haven't cheated anywhere, so fuck you and this jackass accusation that somewhere there's a cheat somewhere, but there isn't. So fuck you. Oh, God damn it. I don't see how it's possible for an electron to attract an electron when they're emitting exclusively electron force. I mean, that's the simulation, okay? The red bits that go in change to blue bits, okay? Red bit goes in, changes to a blue bit. So this can only reflect blue constantly. Just like Maxwell's equation, just blue lines coming off the blue object, just red lines coming off the red object. There's no fucking way a blue thing could attract a blue thing. There's no way a red thing could attract a red thing. Fuck you. Again, you have to watch some of the other videos. I've already been through this. You know, it creates the two objects, the simple little 2 + 2 + 3 rules. Okay, 3 little tiny interaction differences. It sticks, it reflects, and what's the third one? It changes the color. Okay, so the color changes another property. All right. So the opposite bits of force are just changed in their color. No momentum is exchanged. The same color bit hits. It either gets absorbed as momentum or it's reflected. Okay, that is, it reflects and it reflects the other piece of energy that was going in the opposite direction. The component going in the opposite direction. I'm just saying that perfectly duplicates what Maxwell drew as charges. It creates perfect radial inverse square relationships between the objects and creates the idea that the closer they get to each other, the more the energy is intensified, in the sense that they can only gain momentum away from each other. They can't gain momentum towards each other. Oh, shit. Alright, well, I guess we're winding down. There's not much happening here. Let me just see how many participants there are. 13. Yeah, marginal. So, whatever. So, 2-minute warning, 30-second warning, whatever. Yeah. Alrighty then, so till the next time and such and so forth and whatnot.